Geometry Notes 9-3, day 1. Actually, it's just day 1. We're doing the whole deal. We're going to skip a couple things in your notes packet, so pay attention. We're going to be kind of doing a little bit of a dance because some of the stuff we're going to be still doing together at the first part to start you on your assignment will, kind of get us into that assignment. But a couple things I first need from you is, does everybody have a protractor on their desk, the orange thing? Okay, so if you don't, raise your paw. And, because you're that strong, raising your paw up, I am going to come around and drop off a protractor. Your paw, your dad. Okay. Yeah, Dad's up here. Okay. All right, yeah, just grab one that's there or something. Now, to the boys, and I always have to say this to the boys because the girls, they don't do this. Guys, these are made of plastic. They will not be too impressed that you can bend them. Now, if it was a 6-inch solid steel bar and you went, I'd be like, ooh, that's cool. But because it's made of plastic, not too impressed, okay? So don't be ripping it apart. Yes, Colinda? You need the 7? Oh, I gave you a 7? I'm sorry. I gave you an 8. Let's see if it's this one. It gives a no name. We will just erase that name. You'll be fine.
Thank you.
That, it says 8, right? Thank you. Okay, so now here's the deal. We're on page 11. Key concept, rotation about a point. So let's get this thing going. Okay, now a couple things. Before we even start, don't sketch this. We're going to do this together. Just wait a second. I'm just going to pull this over for a second. What I want you to do is recognize that corresponding points, V, R, and V prime, okay, corresponding points, make an angle through the center of rotation. Corresponding points make an angle through the center of rotation, okay? In this case, it's general x degrees. But that angle is the same angle made with corresponding points. There, that green angle and the blue angle, they're the same, x degrees, okay, in this case. If I further connected my W, R, and W prime, what do you think angle would happen? Are you okay with x degrees? There's like a theme. The same degree value for all 3 angles would exist if I'm rotating a figure around a fixed point, a certain degree value, okay? Now, how do we make that angle? First thing I want you to do is introduce yourself to your protractor. Right now, you might be a rookie tractor, or you might be a semi-pro tractor. By the end of today, you're going to be able to be a pro tractor. So the protractor, yours works a little different than mine. What I want you to do is just kind of put it down and make a ray, okay? Make a ray, a horizontal ray going across notes, about the same spot in notes that on the same page that we're on, so above that unless stated otherwise statement. That's all we need. We just need that amount of room. Okay, so you've got that in there, you're going to put it down. Now, with that done, you're going to make a couple marks on it. First one is going to be B. Next one, over here, you're going to call it A. And now I've got some people going, Bloom, that's a segment, it's not a ray. I know, just humor me, I'm old, okay? What I want you to realize is right now we have a segment, or ray. We can now measure out 60 degrees. I want you to line up the 0 of your protractor, okay? So that way, we're going to use the inside numbering scale, starting at 0 and working our way to 60. When we get to 60, we're going to mark on the outside of our protractor where that is. And then I have to take mine away, and so do you. And I'm going to put in my 60-degree segment right there because I measured that earlier. Okay. What you're going to have to do is go ahead and twist your protractor and have it be a straight edge for you here, and you're going to connect where you drew your little dot and your B. Okay, extend it well beyond what A is, because I want to talk about how I'm going to measure this. Okay, now they're looking really good, folks. You're doing a great job. Now, without a ruler, we're going to kind of copy the length of AB. And people are like, what do you mean by copy the length? Kind of clean off the bottom straight edge part of your protractor. And with your pencil, notice how I said pencil? It doesn't work really great with pen. It does, but it scratches the crud out of the protractor. You guys are going to put the corner of your protractor right on the vertex, and you're going to go over here and scratch, actually mark with your graphite and your pencil where A would be, right? On your protractor. You're using the edge of your protractor on B, and you extend it along there and just mark your protractor. You can do this with a piece of paper too. I mean, it's not incredibly nasty. What you just did from the edge of your protractor to that mark, that's the length of AB, right? You just copied the length of AB onto your protractor. Does that make sense? Now, all I want you to do is take that length, that measurement you just made, and apply it to my red ray, or your ray that goes up. So you're like, what? So I'm just gonna make mine adjust a little bit. I just gotta see where it's at. I gotta make it smaller so I can see how it's gonna work. Yep, that'll be fine. I'm gonna turn it, I'm gonna move it. And remember, it was on the corner. I'm gonna turn it without changing its size. It was on the corner. Still gotta turn mine a little bit more. Yours is way easier to deal with than mine, trust me. I would prefer having yours. Okay, well, I have my A right here. Okay, that's my A. I wonder if I can move it. Good, that's my A. Are you okay with that? Ideally, are you all right from this point, A prime, to here? So this length, ideally, is the same as this length. Are you okay with that? Now I'm going to tell you what we just did, because you're like, why are we doing all these steps? Bless you. You copied an angle, 60 degrees, right? You just drew a 60-degree angle. We drew it opening that way. You rotated point A around a fixed point B, 60 degrees, okay? So that is a rotation of A to A prime. Now, if I were to say rotate this segment, and I was going to call that C, okay? People freak out about this. It's like, the segment wasn't there before, Bloom. It is now, okay? If I was going to rotate this segment 60 degrees in a counterclockwise fashion, I would need to now, the next thing is to make a ray, go 60 degrees, it'd be over here someplace, and then apply this distance, put it over here, and then I'd be able to say, hey, that's C prime, right? That's what rotating a figure is when we do this. I don't have you draw it anymore, because what I really need on a test, I need you to know the properties. And the properties are corresponding sides, corresponding points with the center of rotation make an angle that is our rotating angle, okay? You need to know that property, okay? Every one of the corresponding angles is the same angle, okay? Questions about that at this point? So, we are going to cover this part of that section in notes, so go ahead and get those written in. The center of a polygon, central angle, okay, is the point equidistant from its vertices. We actually call it the radius, or the center of the polygon, and the segment that extends from the center to the vertex is called the radius of the polygon. The center of the vertices and the vertices of regular n-gon determine n-congruent isosceles triangles. And now people are like, what do you mean by n-congruent isosceles triangles? I'm just going to use this area, okay? If I have a hexagon, I have a center. And they're saying, and this is assuming this hexagon's regular. You guys know what a regular hexagon is? Okay, all the sides are the same, all the interior angles are the same. Okay, it's not just a Metamucil drinking hexagon. All these would be the same. Okay, all these interior angles would be the same. How do I know what those measurements are? 360 divided by 6 in this case. What's 360 divided by 6? Are you okay with 60 degrees? That's central angle. So you know what the central angle is. This is 60 degrees. Not only is it an isosceles triangle in this case, but it's equilateral. That's 60, that's 60, that's 60. Wow. Crazy the things you know just based on one thing. Okay. Now, that's how we use this section. We're skipping the rotating things for the next 3 things. We're going to go on to page 12, I hope. There it is, page 12, top. Now, here's the dealio. Check this out. I have a 4-sided figure. Oh, wow, that was kind of cool. It's like a stick man. We're going to group those. Group. I have a 4-sided figure, right? 1, 2, 3, 4. Are you all in agreement? This is a 4-sided regular figure. The other term of it is a square. Okay, I have a square. I have a square that I kind of did some copying of, and I put H inside, I put M inside, I put T inside. Ooh, and I bounced it all over the place. Let's pull that back. Okay, these are there, those are here. These are all the same because that's the radiuses of this square. Okay, the central angle, this angle right here, is 90 degrees. Are you in agreement? Now, here's the deal. We're going to rotate this square. Pretend it's a spinner, and the center of the square is the center of my spinner. So what's really cool is that I get to do this. Okay, right? Pretty fun, right? I got my own little spinner. But now I want you to realize that in this textbook, all the rotations are counterclockwise unless we specify otherwise. So here, I want to go 90 degrees counterclockwise rotation of H about R. H is going to go 90 degrees about the center R. It goes and becomes point T. Do you see how it goes to point T? If I was going to move H 90 degrees and rotate it, it becomes point T. And that is our solution there. Okay, are you all right with that? Yes or no? Head bobbles are good. Smiles are good too. That prevents whiplash in the head, you know, if you're a quick head bobber. Okay, so here's the deal. You guys do the next one. I'm taking M about R is the center. I'm going to rotate it 90, 180. M becomes weird, right? And everybody's going, they're all T. They all got to be T. They're not all T. Okay. Now, they might be. Okay, go ahead. Check out C. I'm going 270. Okay. Now, here's the thing. The multiples on this square are 90, 180, 270, 360. Okay, that's it. This is what I can do. Okay, when I go counterclockwise. When you have a segment, just do the 2 points separately. See if it makes sense. And we'll talk about the segment. But I want you to try it. Go. Give it a try. Some people are done. Some people are like, I don't know where to start. And that's okay too. Okay, but try it. Commit to an answer. Okay, use some sort of form of what you seem to understand this to be right now so we can fix the understanding. If you apply something, it's better than doing nothing. Now, going back to the beginning, please notice I have AT green on the bottom of my square. Okay, so A is right here. I'm just going to focus on A. A is going to go counterclockwise 270. That's 90. That's 180. That's 270. A became T. T became H. That's where I'm going. How did you do? A became T and T became H. I chose A because T was going to drag behind, okay, because A was going to lead, so I chose A for that reason. And people, how did you know it was going to lead? Because when I grabbed this thing, A started rotating ahead of T. A is ahead of T. Now, if T was going to lead, I would have totally chose T to count and come around, okay? But A was the deal. I want you guys to think that one full revolution is 360. If I was standing and you blinked, you closed your eyes, and I'm really a fast spinner, I'm not really, but if I was, how would you know if I moved or not 360 degrees if you had blinked? How do you know that every time you do blink that I don't? Because I'm really that fast. Yeah. Scuff marks. I like that, Bloom. That's awesome. Okay, but would it appear that I moved at all if you just blinked, whether I did or not? No. So if I go 360, HM becomes HM, doesn't it? Now, let's go over the steps that I did. I have to have a regular polygon. I take my number of sides of my regular polygon, divide into 360. Okay, that gives me my central angle. Multiples of that central angle allow me to know how many degrees rotating that figure will bring back to its figure. I bring it back to itself. It's 90 degrees in this case. Okay. Incidentally, even figures will have 180 rotation. Odd figures won't. And people are like, what do you mean by odd figures? Odd sides, number sides, won't come to 180. Evens will. Every even figure will come back to 180 eventually. Okay? So with that information, armed with that, do number 3. Go. Oops, wrong way. Armed with that information, do number 3. Okay, so here's the deal. For those people at home, while this was going on, 9.3a worksheet was just handed out, and it's something that you can print off if you don't have it or have access to it, because it's something we're going to be doing in the next slide or two. Okay, so use the figure at the right. Point M is the center of the regular hexagon, so I'm going to go 360 divided by 6, because it's a hexagon, and I'm going to come up with 60 degrees. That's how I do it. Central angle value. Okay. Now, every time I go 60 degrees, my hexagon comes back to itself. Okay. So it's multiples of 60. 60, 120, 180, 240, 300, 360. That's what I'm be counting. Now, what's the angle of rotation that maps H to X? H going once, twice, 3 times, 4 times, 4 times 60 is 240. And that's where I'm going. Okay. Your turn. Do B, C, D. I have some people that haven't blanked. Get them done, get them done, get them done. See how you doing. And if you are done, kind of glance left and right and compare your stuff with others. See what they have and have a civil discussion. Remember, loudest isn't rightest. Loudest just makes spectacle of self. Should be on an optometrist then, right? If they make a spectacle of themselves. Very few people get those, so I'm okay with that. It's what happens when an optometrist falls into a lens grinder. They make a spectacle of themselves. Okay, all right. That's the real joke, but I tell them poorly, I guess. Okay, so here it is. What is the angle of rotation of E to G? Are you okay with 180? And remember, E to G, we're checking this out. E to G, 1, 2, 3. That's 3. 3 times 60 is 180. And then we got those other ones, 180, 120. So let's talk about what's going on with them. E is going to go to G. So how many, if I'm playing a board game, say Chutes and Ladders, okay, I go E to H, that's 1. That's 160. That's 2 60s, that's 120. That's 3 60s. Okay, 3 moves times 3 60s, it's 180. So it's 180 degrees it'll move. That's how I'm doing that follow through. Every time I click back to itself, it's a 60 degree. It's mod 60 as I'm counting with this. It's either 60, 120, 180, 240, 300, 360 is my answers when I'm working with a hexagon. If I worked with a pentagon, I go 360 divided by 7, and I'll go 72, 144, 216, 288, and 360 in that order. So just keep in mind, it just changes with my shape as I'm doing this. Now, you guys have your protractors. What I want you to know how I set these up. And it looks like, boom, did a lot of pre-work. I just left the old stuff there. This is how I did it. I took my protractor, my straight edge, and went, hey, I have a pre-image I read for what is the angle of the rotation about point B that maps the solid line figure to the dashed line figure. This solid figure is my pre-image. The dashed line figure is my image. I picked the easiest points to be corresponding, the ones that pointed into my rotation. The dot on her cell phone, see, it's dangerous having stuff on your desk. The dot on her cell phone points into my shoulder, right? So here and here, that's the easiest point on her cell phone. Whew, I didn't break it. Okay, easiest point on her cell phone that corresponds. So I'm going to connect my point of rotation to corresponding points. My point of rotation to corresponding points. And then I'm going to measure them with my protractor. Okay? Hey, for those folks at home, you probably have a protractor in a junk drawer. If you have older brothers and sisters, you probably have one of my protractors in a junk drawer. They're orange. It's really easy to find. Go find one. Okay? And get back to us. If it's one of mine, bring it in. Okay? As we're looking at this, I've measured it. Are you okay that it's 90? Or is it 270? How would I know? What's the rule about all the rotations in this textbook? Counterclockwise. So although they're 90, they really went, because people go, well, that's 90 degrees, Bloom. They go there. But that's clockwise. This is 270 counterclockwise. So although we have it, our real answer is that, because it's supposed to be counterclockwise in this textbook. Okay, now I want you to know that there's a connection between clockwise and counterclockwise, because heaven forbid I ask you a question that's a clockwise question. Oh, I know, it's a shocking thing, okay? But you got to keep in mind there's a connection between the two, right? There's also a connection if you use your hips as your angle of rotation and your head hits the desk. That's about, about 75 degrees. It's kind of a drag. Be careful. Okay. Now, do B and pay attention to C. C's tricky. But I'm going to give you a hint on C. It's not going to be any more than 180 because 180 brings it back to itself because of the symmetry. So it's going to be something. But I need you to remember, find corresponding points that make sense and go ahead and measure them. I'll give you about 2 minutes. It'll take that much time to do the two. And on the B one, pick those points that point away as the corresponding points. They'll be the easiest ones to work with. So pick these guys. That's how I did it. So after I picked them, I went in here and went, oh, well, that's a corresponding point. And I went, oh, that's a corresponding point. And I measured that angle. Okay, so get yours measured, get it done. Okay, movement's good. Non-movement, you might be brushed off without, swept out with the trash. Okay. I was worried about your head. I was like, geez, I'm not that boring. Oh, I might be. I might be today. Okay, remember, we're still measuring. Every time we measure, there's two numbering systems when we set these up. Okay, so be careful on which one you're doing. Start at 0. If I'm going over here, if I'm starting here, I start here at 0 and I go up. Boy, that's looking like I'm at 130, isn't it? Okay, so when we're doing this, make sure that it's 130 counterclockwise, 130 counterclockwise, or 230 clockwise. And people are like, how do you do that? Well, when I got these set up the way they are, the two values should be 360, right? Because it makes sense as I'm going around the plane there from my center. But in C, I'm only concerned about rotations of 180 or less because of the symmetry of the object. So when I do C, okay, I've got this set up, and I decided to go from this right, I don't know, arrow tail to this arrow tail, and I measured them, okay? And that was 70 degrees, but I did it clockwise for 70, but it's actually 110, because remember, it comes back to itself. That went 70 degrees, but if it was 110 coming counterclockwise, because 180 comes back from the original, so we're totally fine with 110 or 70, or even, I could say 290 if I say that's the head and it's coming around, but because of the symmetry, I don't have to. Are we okay with this or not? Is it making sense? I need questions. What do you have? How do I line the protractor up with them? Well, the biggest thing when I line up the protractor is this B's got to be my center, okay? And then this lines up with one of my rays. And since I'm lining this up with my ray, I start at 0. And there's two number systems. I start at the one with 0, and then I follow it around to where it comes in contact with this. And this is apparently really not coming in really well because every other class was 130 and now this one isn't. So I put something in the wrong spot. So it's about 128 right now, okay? But the last 3 hours is 130. But that's all I'm doing with my measurement. Does that make sense? Okay, and one of the issues with this as a grader is because as we have so many errors to set up my rays, I need you to know about the properties and realize how they work, but I will give you solid values somehow in you applying the properties to get the right answer, okay? Like in letter D. Letter D is a lot like the previous one we just did, okay? Notice that it's a tire and it has repetitive pattern. So I got a repetitive pattern in my tire. How many times does that pattern repeat itself? 9 times. So 360 divided by 9. I get a 40. Now, be careful. Which direction are we going to use? Because they don't specify, we assume it's counterclockwise all the time. So they're asking, hey, you're going to go from Q around to X. How many degrees did you go? And really the question is, how many spaces did I go, or how many of my segments did I make from my polygon? And I went 6 units. I went 6 times 40, because each one's 40. I'm going to go 240 degrees total. Does that make sense? Okay. Those make a lot more sense. People can see them better, but it's the same type of question that I did with C. Okay. Now, turning our page to page 13, I want to answer number 5. Answer number 5. And then from number 5, we're going to go to the yellow sheet. Answer number 5. Go. From number 5, we'll go to our yellow sheet. figure if I got to have something hands-free that long, I've got to use a computer. Okay, so here's the deal. How many sides or how many pieces do I have in this? 12. 360 divided by 12 is what? Okay, so 360 divided by 12 is 30. I'm moving it 2 spaces. 2 times 30 is 60. We're done. 60 degrees rotation. Rotation moves 2 spaces. Now, what was really cool is we didn't specify which direction, and we automatically all assumed it was going to be right there. Okay? Now, read at the top of your yellow worksheet. That. Another transformation of geometric figure is called a rotation. A rotation turns a figure in the coordinate plane around a center point. The origin 0, 0 will serve as the center rotation for the rotations we will be focused on in this lesson. The positive number of degrees a figure rotates is the angle of rotation. Unless stated, positive rotations are in the counterclockwise direction. It's like a one-hit wonder, right? The pre-image and image under a rotation are congruent, thus a rotation is an isometry. Please keep in mind that the only rotations available on the XY coordinate grid are 90, 180, 270, counterclockwise and clockwise, incidentally, but we're all studying counterclockwise today, okay? So what I need to do is recognize that I have my original P. It's actually listed for you. I have the original Q. It is also listed for you. I want you to find Q prime, and I want you to find P prime, and put them in. So P prime was -1, 2. Q prime is looking like -2, 4. What happened? People are at home go, I know, I know, I know. It's like, yeah, I can't hear you, I'm sorry. Okay, but here, didn't I do that? Didn't I multiply by -1 on that? I now have my rule for rotating 90 degrees counterclockwise. I want to make sure that's clear, so we're going to go CCW. And this is a rule you better have in your notes. Okay? CCW. Your turn. Do the next one. Are you invisible, man? I think you're using your powers for bad. Okay? With great power comes great responsibility. You just got to make sure you just don't like hide. I'm sorry, I can't count. I'm a math teacher and I can't count. I know that. So again, P is blue. Might as well work with my blues, and this is really far off. I'm not sure why that's that far off. Q is going to be my reds, and check them out. Q is still 4, 2. P is still 2, 1. P prime, though, is -2, -1. And Q prime is -4, -2. What did I do to both points? And people are like, why is your voice so high, Bloom? I multiplied them both by -1, right? So my rule is multiplying my x's by negative and my y's, and they stay in position. And again, I'm not going to put CCW or CW by this because it really doesn't matter. 180 is the same whether it's clockwise or counterclockwise. Okay. Incidentally, corresponding points when it's a 180-degree rotation about the XY coordinate grid make a line, I should say, that go through the origin. Weird, right? Do the last one. 2, 1, I use red. 4, 2, still 4, 2. Okay, cool. And now I've got positive 2, -4. And I have positive 1, -2. What's the rule? I take my y and put it here and take the opposite of my x for counterclockwise rotation of 270 degrees. So those are the rules I get to apply. And I always have students go, well, huh? I've got 3 rules, one for 90, one for 180, one for 270 counterclockwise, right? I now turn the page. I need to find my original points and apply the rule. I have the original points. I've got 3, 4, 5, 1, 3, 1. Okay, I apply them according to that rule that's up there. I take my y, take its opposite, -4. Put it in the x position. The x is 3, put it in the y position, I'm done. In b, to be b prime, I take my y, take its opposite, put it in the x position, take my x, put it in the y position, I'm done. The next one, -1 goes there, and 3 here, and I'm done. And people are like, what? I just pop it in there, and now this is my shape, rotated 90 degrees, clockwise rotation, okay, around the grid. And that's where we're going. You do number 2 the same. And number 4, I am working with 180, so I just multiply my original values by -1 and I get them done. And 5 and 6 on this sheet, I apply those other rules that we have, and as soon as I'm done working with this sheet, I have about 8 more minutes of homework time, and I'm done. Okay, we won't correct your assignment for yesterday today because we won't have time. I want you to finish this in class. Okay, and you will, because we have about 13 minutes. I can't think it taking longer than that. May I steal this for a second? There are issues though, because I'm old and feeble and I type horribly. Problem 9, 10, and 12, you just don't have a point to go around. We'll do those together tomorrow just for fun. 9, 10, and 12 on the main part. Okay, just kind of circle those, just know we can't do them. And keep in mind, I'm going through therapy because on the very back sheet of that, I left it blank. I had space to put like 15 more problems, and I didn't. I had the hardest time not doing that. Okay, so my doctor and I are going through it. We're working through that. Okay, didn't want to hurt you guys too bad. Okay, I hope things are going well. You guys have a great night.